Okay, I think that we can start. Hello, everyone. I am very happy to having you, Jimit Raithatha, in this ArquitecTI. We had a chat with Jimmy Raithatha in Reinvent 2024. When I heard Jimmy, I thought immediately that we need to hear Jimmy in this community, in our community. And I am very happy. Jimmy is a Chicago-based senior architect with extensive experience designing and building cloud infrastructure at the scale. He currently leads an infrastructure team at a major US banking institution where reliability, performance, and resilience are critical. In this talk, beyond single regions, engineering the multi-region debates, Jimmy invites us to explore when moving to a multi-region architecture is worth it. What are its advantages and risks, and how to evaluate traffic pattern and cost consideration to avoid over-engineering. We invite you to make the most of this ArquitecTI. Welcome, Jimmy. I am very happy to having you. I mentioned many times this because I am really happy. I think that this talk is very valuable for our community. Welcome, Jimmy. The floor is yours.
Thank you, Nicholas, for the wonderful introduction, and thank you everyone for joining. And the pleasure is all mine. I am very happy. I'm grateful to be invited to share my learnings over the last few years with everyone. I hope that what we discuss here will be useful to you. So let's begin. So I will again do a quick introduction of myself. I currently work for JP Morgan Chase. I'm based out of Chicago, and I am a cloud architect. At this point, I have accumulated about 15 years total in technology, out of which 8 years has been in financial industry technology. And in the last, I have about 5 years of experience in the cloud ecosystem, mainly AWS. And I have about 3 years of experience, 3 to 4 years of experience designing large scale multi-region environments that need to process traffic at high throughput and low latency. So let's dive in. I just need to go through a disclaimer quickly for reasons. So I'll just quickly read through this. All of the views experienced in this upcoming discussion are my own views, and they do not represent the views of my employer. The information shared here comprises recollections of my general experiences and challenges faced while designing cloud environments. And all of the information presented here is publicly available once you do the research for it. So there is no confidential information discussed in this talk. Let's quickly look at the agenda for today. We will first begin by exploring what multi-region infrastructure is. Like, we are all aware of the term, and we'll just go through quickly what it looks like. We'll also explore who needs multi-region infrastructure. I can tell you not everyone needs it because it is expensive to run multi-region environments. Cloud providers have figured out ways to charge customers for every small thing that they process. So we'll explore who needs it, who may not need it. Next up, we'll look at some cost considerations. What cost gotchas or what stuff you need to watch out for when you're designing multi-region environments. And lastly, we'll go through some technical design elements. So these are the 3 main items on the agenda. The focus area for my talk is going to be AWS, EKS, and Kubernetes, financial industry, and some nuances. So by nuances, what I mean is that in this talk, I want to avoid sharing information that you can just easily look up online using Google. So I will try to. We are not here to discuss how to create DynamoDB global tables or how to set up data replication between two regions in in a cloud environment. All of that information can easily be searched for on Google. What I will try to cover instead is the challenges, pitfalls, and some of the gotchas, some of my experiences that that I gained only after I designed and implemented large-scale multi-region environments. So that's what I mean by nuances, and the focus area is where my expertise is. Hence, as a result, I have chosen to focus on these four aspects. So let's start. Multi-region. What is multi-region and who needs it? So this is a standard diagram, 10,000-foot level diagram of a multi-region environment where you have your application either running on an EKS cluster or an ECS cluster or even on EC2 instances, running in two regions. Then you would also have, if your application is dependent on data, you would have a database solution deployed into both of your regions. And if the application is interacting with files as well, then you would have file storage along with your application. There would be a global DNS endpoint that points to both of your regions, and clients would be accessing the multi-region environment via the global endpoint that routes traffic to both the regions. Now, if your application is dependent on data and needs a database or file storage, it is in most cases, it is likely that you need the same data to be available in both the regions. So in most cases, the multi-region environments would have data replication set up between the data in both the regions. And then there are three different types of multi-region implementations. Again, as you know, the first one is active, where both of your regions are running all of the services, and both of your regions are receiving traffic from the global DNS endpoint. There are multiple ways to route traffic to different regions. There's latency-based routing. There is failover-based routing. There is weighted routing, and you'll be able to explore. There's a lot of documentation available for all of these routing mechanisms online. So you'll be able to find a good amount of information there. Active passive is where you run your application in just one region. In the passive region, the application is deployed, but it is not running. And the majority of the times, the reason for deploying active passive environments is cost. Cloud environments are always expensive. So in some cases, it makes sense to keep a passive environment available to use in case of disaster, but not keep it running all the time. And the third one is active warm. I haven't seen too many active warm implementations being utilized. A warm environment is you still have your services running in a second region, but they are scaled down. So if your service is running, it requires, say for example, 10 pods to run inside an EKS cluster. 10 pods, to serve the volume of traffic that you're receiving in the primary region. Then in the warm environment, you would be running like 2 or 3 pods, just so you can fail over quickly in case of a disaster. So these are the 3 high-level implementations that I've observed in my experience. Next up, let's quickly discuss who needs multi-region. So as architects, as executives, as engineers, there are some questions you need to ask or discuss with your team when approaching multi-region implementations. Questions like, how badly were we impacted from the recent cloud outages? As you know, AWS and Azure both had major outages in October 2025. You need to sit down, collect the impact, analyze the impact from those cloud outages. And how do you analyze the impact? You go through some of these additional questions like SLA and client commitments. Have we made promises to our clients stating we will be up for we will always be we will be up for a certain percentage of time every year, and are there do we have to pay penalties to our clients if we are not up for that much amount of time in a year? The next question, you could ask internally or yourself is, was there revenue loss during the AWS and Azure cloud outages in October 25? Did we lose more revenue than the cost of running cloud environments for running multi-region environments for an entire year? Next, does our application have traffic reprocessing capability? So if you missed some traffic because of a cloud outage, is the application able to recapture all of the traffic that was missed? In some scenarios, it is possible to recapture the traffic, like if the traffic was stored on a queue or a Kafka cluster, and the application is listening to the Kafka cluster, the queue or clusters are going to permanently store the messages for a few days. When you back up, you'll be able to reprocess those messages. But what about synchronous traffic? What if you are a payment provider and you are processing payments for transactions coming in from all of the retail stores? Like somebody is standing at a grocery store and trying to swipe their card, and you are the payment processor for the card swipe. In that case, if you have an extended outage, you are essentially going to lose that traffic. There's no guarantee the customer is going to come back and shop for the same stuff, or the customer might choose to pay cash, right? So you lose that revenue permanently if you are in a single region and there's an extended outage in a single region. Okay. What about reputation impact? Sometimes reputation impact is also very important to consider. Consider sites like Mercado Libre or America Movio or the largest cell phone provider in Latin America. If they are unavailable, if they are down even for a few hours, then the reputation is going to suffer. So are you also large enough to suffer reputation impact? Are you going to be in the front page of the newspapers in your country if you undergo an outage? Sometimes that is also an important aspect to consider. Is your service of systemic importance to your country or your region, right? You might be a provider of public transit services, or you might be an application that controls the traffic lights in majority of your country. So you have to ask questions like these, then make a decision whether you need to be multi-region or not. Let's look at some cost considerations as well. Where is cost incurred when a multi-region environment is built? So let's start with, is multi-region expensive? Yes, it is very expensive. And I'll show you why. So as soon as you begin building infrastructure in more than one region, you start incurring some fixed costs. Okay, consider an active environment. And consider an EKS cluster. So if you deploy an EKS cluster to a second region, even before you can deploy any of your application services, you will have to, EKS is going to consume at least four to five nodes to run the control plane. Control plane includes services like the kube controller, the DNS service, the kube proxy. EKS needs to run those services before your application can be deployed into the cluster. So this is one of the fixed costs. Next, another kind of fixed cost is, assume you have a small, even if you have a small service, that is running, and two pods are enough for that service, to serve all of the incoming traffic in one region. When you deploy the same service in a second region, you cannot essentially deploy less than two pods in a second region, because if you rely on only one particular instance or one pod of your service, then you are introducing, risk into the system. Like that one pod, if it goes down even temporarily, your service will undergo an outage. So you need to run like a minimum number of pods, even in your second region, for the region to be available to process incoming traffic. So that is also a fixed cost. Now, if you have a service running with 10 pods in a single region, then you could divide the 10 pods into 5 pods in each region, but not a service that is already running with a minimum number of pods in the single region. Next, data replication. If the application is dependent on data, then data replication is also very, very expensive across all of the cloud providers. Then there are some variable costs that you need to think about. Headcount. In my 15 years in the industry, there is one behavior I see pretty frequently from technology managements. No offense to anyone who is in technology management and on this meeting, but there is this myth or misconception that infrastructure teams or the number of infrastructure engineers do not need to grow when the application grows or the number of developers in a team grows. As your infrastructure expands, your workload actually expands along with the infrastructure expansion. Think of things like fixing vulnerabilities, maintaining and upgrading the infrastructure. If you go from single region to multi-region environments, all of that essentially doubles. You now need to upgrade 2 environments, you need to maintain 2 environments, or even multiple environments if you expand to additional regions. So the same set of engineers is not going to easily be able to take on all of this additional work that comes in when you go multi-region. So you need to think about headcount as well. And of course, maintenance, upgrades, essentially what I covered. So what you're going to observe if you're running an active, or even an active warm environment is that the multi-region cost is going to be anywhere from 1.5x to 2x of what you're spending on a single region.
Jimmy,
yes.
We have 2 questions. The first question is, what are the most common strategy in a multi-region disaster recovery? What do you think about that?
Can you repeat the question?
What are the most common strategies in a multi-region disaster recovery?
Okay, so there are two strategies which are very common. The first one is, use an active environment and only fail over incoming traffic if the traffic is being processed in a synchronous fashion. So if we go back to the multi-region diagram, let me quickly go back. Yeah, here. You have two environments. You should have a single endpoint controlled by a DNS service such as Route 53 that is routing traffic to both the regions. And when there is a disaster, you need to devise a mechanism to update Route 53, make Route 53 health checks in the disaster region fail so that traffic can get routed to the other region. There are multiple ways for how to make Route 53 health checks fail for an impacted region. The first one is Amazon provides a button in the AWS console, which is like, invert health checks. So you enable health checks for the underlying load balancer in Route 53. When you want to exit a region, you essentially invert the health check so that it is considered failed. And then Route 53 knows about the region's failure and it will route traffic to your other region. There are also health checks that you can set up directly on your services. So the services should have a health check endpoint that reports back, that the load balancer is monitoring. And Route 53 should be monitoring the load balancer. So if a service is impacted, then it should be sending back an unhealthy response to the load balancer. Route 53 monitors the load balancer, looks at, realizes the unhealthy response and fails traffic away. There's one very interesting, there's a catch here that we are actually going to cover in the second part of this discussion. So this disaster recovery strategy was for an active-active environment. For an active-passive environment, what you would need to do is first start up the passive environment and do validations, make sure the passive environment is ready to take traffic, then shut down your active environment. Yeah, that would be a disaster recovery strategy for active-passive environments. If you ask me personally, I'm wary of active-passive implementations because it always takes a long time to start up a passive environment and do all of the validations on it, So your customers might see a good amount of disruption before your passive environment scales up and is ready to take traffic. So active-active is actually, the first implementation to target if the cost is palatable to your team or your application. Yeah. Let's talk about one more disaster recovery scenario. Say the application in both your regions is listening to asynchronous messages, Kafka or messaging queues. In that case, the quickest way, to exit a region and move into another would be to immediately scale down services in your current active, scale up the services in your new active so that they can start listening and reprocessing all the messages. It's one good thing about message processing systems is that the messages stay on the message processing systems for a while. So it is very easy to reprocess messages if you're listening to just a Kafka topic or a messaging queue. Does that answer the question?
Yes, perfect. Thank you so much.
Okay. I see one more question as well. What about Pilot Lite? I have not done enough research on Pilot Lite to comment confidently on it, but if you are welcome to leave your email with Nicholas, I will get back to you on it. Okay, let us now go through some technical design elements. These are the nuances that I was talking about, stuff that I learned only after designing and implementing multi-region environments myself. So the first question is, okay, where do we place the additional regions if we want to go multi-region, right? All the cloud providers have so many different options available. Yeah, there's AWS has US East 1, US East 2, California, US West 1, US West 2, Oregon. They have a region in Mexico, all over the world. So where should we place the applications? One very important aspect I'd like to highlight is to make sure you are aware of the difference between your client's location and the client's infrastructure's location, because the application is always going to receive traffic from the client's infrastructure. And the client themselves might be in a region, again, different from where the client's infrastructure is. So this is something very important to consider. Let's go through two scenarios to understand how this matters. Okay. So scenario one is where you are receiving synchronous traffic directly from the user. So a user might be clicking a button, submit button on a website and waiting for a response from your application. Or the user might be calling an API, or the user might be performing some operations that call your API, and the operation is waiting for a response from you. So if the users themselves are located in, say, US West 2 region of the United States and US East 1 region of the United States, then you will be able to provide the fastest response to them when you also place your infrastructure in the same regions. Right? This is because you're receiving the traffic directly from the user in those locations, and it is synchronous. If you are in a single region environment, then what would happen is, say you are in a single region environment starting with US East 1, users on the northern side of the United States, or users that are closer to the northeast side of the United States, will receive good performance, but users that are far away from US East 1, Northern Virginia, will experience some latency. So cloud providers like to claim that between regions in the same geography, the latency is somewhere around 50 milliseconds if a user is 3,000 to 4,000 miles away. But what I have observed in my experience is that the latency can be anywhere from 50 milliseconds to 200 milliseconds extra. So in a synchronous scenario, it's necessary to place your compute infrastructure where the users themselves are. So for a synchronous scenario, the correct region choice would be US West 1 or US West 2 when you add, as your second region. If your first region was US East 1 and you have customers from the East and West coast of the United States. Let's look at a second scenario, which is your application is reading messages off of a Kafka cluster, two sets of Kafka clusters, that are sitting in the US state of New York and the US state of Delaware. Okay. So, and users or user systems or client systems from, say, Mexico, Brazil, and Chile are writing messages to the Kafka cluster. In this case, the users or the user application themselves are quite far away. You are receiving traffic from New York and Delaware because that's the infrastructure that the multi-region application is interacting. So in a scenario like this, the correct region choice would be US East 1 and US East 2. So these two regions are the closest to New York and Delaware. And to avoid latency, US East 1 and US East 2 regions should be selected, Okay, database considerations. If the application desires identical processing time from all of the regions, then the application is going to need a multi-master database. This is multi-master offerings are new offerings that have gained prominence in the last, I would say, 8 to 10 years or so. And what is at a high level multi-master databases, what they do is you would be able to install the database in multiple regions, and the databases are able to accept writes in all of those regions, and they are also able to process writes with the same throughput from all of your regions. Let's look at some true multi-master offerings. What do we have out there? There's Amazon DynamoDB. There's Amazon Aurora DSQL, which they introduced at AWS reInvent last year. There is CockroachDB, and there is, of course, Oracle Golden Gate, one of the first ones to provide true multi-master. There is Azure Cosmos DB. Okay, all of these databases can be installed in multiple regions, and they can process writes from all of those regions. The writes from all of the regions, in most cases, get replicated with a last write wins algorithm. Okay. And one thing to note is that multi-master data replication is quick, but it is not instantaneous. So if you have a database running in East and West, if you write something to the West region, the data will take anywhere from 100 milliseconds to sometimes up to 1 second to get replicated and to become visible in your other regions. So because the replication is not instantaneous, what the application should be doing is, do not process transactions partially in one region and partially in another region. So if you're processing transactions, finish all of the processing, reading and writing of the database, writing of database data in the same region. That way, as soon as you write any data, it is even immediately available to you for reading. Yeah, ensure transactions fully processed in one region. Yeah. Cross-region read-writes are, cross-region read-writes in the middle of a transaction are not essentially a good idea, because if you're receiving a lot of volume, the replication might take a little bit of time to finish, and then you might miss some data if you're writing from multiple regions at the same time in the same transaction. So try to avoid that. There is now multi-master offerings are again expensive. There are some cases in which you will not be able to live without multi-master. Like if you're receiving a lot of volume, 200 requests per second, 300 requests per second, or even more, or somebody like Visa or MasterCard, 1,500 to 2,000 requests per second. You have users spread all over the country. You will not be, in order to provide the same customer experience for all of the regions, you will have to use something like a multi-master database if the database operations are part of your synchronous flow. Okay. Now there is one offering from Amazon that I would actually like to highlight. Multi-master is expensive, but this particular offering, Amazon Aurora Global Databases, is a lower cost alternative. It provides you with a pseudo multi-master the architecture. So what I mean by pseudo is, like, Amazon Aurora Global Database, once you deploy it in more than one region, it still has a primary region, and a secondary region. But the one thing that is unique to Amazon Aurora is that it allows you to write information even from the secondary region. So even from the secondary region, you will be able to perform writes. The catch is that you need to enable global write forwarding. And what it essentially does is you would be able to perform write operations from the secondary region, but they will be forwarded to the primary region. The write operations will not actually be performed in the secondary region. Now, secondary region writes get forwarded to the primary region. One thing to note here is that sporadically, intermittently, you will see high latency when write forwarding occurs. Because what happens is if you write from a secondary region, the database query actually waits for the write, like your application will only receive a successful response back from the database once the write has been forwarded to the primary region and committed into the primary region. So sometimes you will see latency when using this Amazon Aurora Global offering, but that may not be a concern, right? If you remove the database operations from your primary transaction flow. So what you could do is, like if you're receiving synchronous traffic, you receive the traffic, you immediately send back an ACK response to the client stating, hey, we got your request, and here's the result. If, as part of processing that request, you need to write something to a database, you first hold those operations in a queue, and then eventually write them to the database in an asynchronous fashion. So if you are able to remove write operations from the synchronous transaction flow, then this would be a very nice database offering to consider, because it can be Amazon Aurora Global databases can be made to incur very low cost. Like if you use the serverless mode for Amazon Aurora Global databases, you are able to scale down the databases, scale down your database when it is not in use. In fact, it allows scaling down even to zero. So you will essentially will not spend any money if there is no traffic. Be aware that if you allow a database to scale down to zero, when it suddenly receives traffic, it takes about 15 seconds for the database to properly wake up and process the incoming reads or writes. So but all of that can be addressed if the database operations are not part of your synchronous flow. So I'll stop here because I think there are a couple of questions. Talking about multi-master databases, could this scenario works using on-premise database and database deploying in the cloud? The answer is yes. On-premise environments, there are limited offerings. The most successful one being Oracle Golden Gate. Oracle Golden Gate can be deployed in an on-premise rack cluster, and it's synchronous. Golden Gate is very, very powerful. It synchronously replicates all of the incoming data into your second data center. It can listen. It can basically it will offer writes. It will allow writes from all of your regions, and it will synchronously replicate all of that data as soon as the the data is committed into the database in any one data center. It is expensive, but definitely possible. And in my past life, I was a part of on-premise environments where we were utilizing Oracle Golden Gate to provide to create a multi-master database. It works very well. The only catch is it is, of course, it's a complex implementation. So you will need to have someone on the team who understands Oracle Golden Gate specifically, like a DBA, because it does need Oracle Golden Gate does need a significant amount of maintenance. There are like write collisions, so you need a DBA who knows Oracle Golden Gate inside out on the team if you decide to implement multi-master with Golden Gate. Okay.
We have two questions more.
Yes, go ahead.
The first one is, in your experience, is a multi-region strategy really enough for problems like DNS failures?
Can you repeat the question, Nicholas?
In your experience, is a multi-region strategy really enough for problems like DNS failures?
Okay. Actually, it may be enough. In the environment that I'm currently working in, it was enough. On October, so we have this application currently deployed and running in production that is taking synchronous traffic via load balancer. And the way we've set up our Route 53 is that Route 53 hits a specific endpoint on the load balancer, which is a health check endpoint. The health check endpoint, in turn, basically receives responses from a service running in the EKS cluster. And the service is going to send back a 200 response if a region is set to active in one of our. So we have a DynamoDB table with values for all of the regions. US East 1, active true. US West 2, active true, active false, things like that. So the EKS service monitors the value in the DynamoDB table, and Route 53 monitors the EKS service via the load balancer. If we, in our DynamoDB table, if we change the flag for a region to false, then the service responds back with a 500 error to the load balancer. Route 53 notices the 500 error, and it stops sending traffic to a region. And on October 20th, what happened was the EKS service was temporarily, there was a DNS issue, as you would remember. So our EKS service was not able to reach DynamoDB. We were observing DNS errors from the service to DynamoDB. So the way we've written our service is that if DynamoDB is unreachable, or if the flag is false, send back an unhealthy response to the load balancer. So our application actually failed over automatically because because DynamoDB was not reachable via DNS, and Route 53 observed an unhealthy response from the load balancer. So in that particular scenario, it was actually enough. Now, if there may be some expanded use cases where it would be nice to have additional mechanisms as well. We can discuss if you have some additional scenarios in mind to cover.
Okay, perfect. Thank you, Jimmy. We have another question.
Mm-hmm.
The other question is, I am wondering if there is any suggestion or a strategy to handle FinOps or cost control for services used in a multi-region implementation.
Okay. So the majority of costs in a multi-region environment are data replication. So for all of the cloud providers, replicating data from one region to another is very expensive. So to control costs, what you could do is not just don't replicate all of your data, replicate only some of it, data that is absolutely necessary for you. The other solution, to control costs is use more affordable database offerings. For example, if we go back to this list of true multi-master offerings, all of these are expensive. Try not to use any of these offerings. Instead, use a solution like Amazon Aurora Global Databases, that can be scaled down when you're not using them. This is the second. This is something to consider. Aurora Global Databases are very close to my heart, because not all applications. If you are not a large application, you don't need a multi-master database. You'll just be throwing money away. Okay, and the third, something else I would recommend you consider is, look at the application services. Sometimes, like when everybody is starting out and building cloud applications from scratch, it is human tendency. When you don't understand something, you sometimes end up over provisioning it. So there may be some savings you might be able to get. Like, look at your services. If you're running with 5 instances of your services, or 5 pods of your service, maybe 4 is enough, maybe 3 is enough. So you might be able to gain some cost advantage there. Then I would look at, so I'm aware of Amazon having Trusted Advisor, and it also has a couple of other tools that suggest to you where you should where you have opportunity to lower your costs. Look at those suggestions as well. And oh yes, 2 more things. Spot instances in development environments. Most teams would be okay with some disruption. So start leveraging spot instances, even for EKS and ECS. Spot instances, we actually just implemented spot instances in our environment here where I work, and I'm very excited to see the results of it next month. If this talk was next month, I would have more results. But leverage spot instances, and we have this the next one is, we have this very I love this framework that we have, where I work, which is like, there is a light switch framework available to all of us, which is, using that framework, you can set a schedule for when all of your instances, EC2 instances, should get shut down, and another schedule when all of your instances should start back up. So think of Saturdays and Sundays. Most application teams would not be working in their cloud environments on Saturdays and Sundays. So you could set a schedule to wake up your environment at 8 a.m. every morning, shut it down at 8 p.m. in the evening. We use that framework heavily. It's internal to JP Morgan, but it's easy to implement something like that. So the way it's implemented is, there's a Lambda function that runs every 15 minutes in all of the AWS accounts. Each account has its own Lambda function. When the Lambda function runs, the schedule says it is time to shut down instances in that account, it just goes and shuts down everything. We also leverage something like, in some environments, we only set a shutdown schedule. We don't set a wake up schedule. Like, think of a performance environment that you need only when you're doing some kind of performance testing, right? So why wake up that environment every day? Instead, what you could do is just ensure that you shut down the environment every day in case somebody started it, but do not add any wake up schedule. Just, users can wake up the environment themselves when they want. So these are some of the strategies you can use to keep your costs down in a multi-region environment. All right, cross-region reads and writes. Let's cover some stuff for how cross-region reads and writes work. So if you are a large application, you are going to run into scenarios where you need to keep data in a specific region. So it could be due to government regulations as well. Many governments have recently started introducing legislation that states data about users from our particular region or our particular country needs to stay in that region. And it may not really be practical to have your compute in all of your regions where your data is, where your data is residing. In some cases, it's practical, but in a lot of cases, it may not. For example, if you are active in a region, but the traffic is not, there isn't a lot of traffic coming in from that region, but you still need to store the data for that region in the region, then what you could do is you could consolidate your compute into one or two or three specific regions. Just read the cross-region data, finish processing it, store it back into the same region. That way you are still following the data residency regulations. Okay, so if you're say you have consolidated your compute into North America or South America, and you need to read data from far-flung continents, then the out-of-the-box implementation to achieve something like that is via the internet. So you have your VPC1 in which your app is running, and you have your VPC2 where VPC2 that in another region that you need to interact with. So the traffic flow would in the standard implementation be, your app may be running in a private subnet in a region in VPC1. From the private subnet, the traffic is going to connect to, a route table in your public subnets, a route table and a internet gateway that you have to install on your public subnets. From there, the connection goes out to the internet. From the internet, it would go out to the load balancer in your VPC2 and there interact with your app in VPC2. You might also have scenarios where you need to read data from S3 buckets or DynamoDB tables or some other databases in your secondary region. So this is the standard out-of-the-box implementation if you don't want to customize too much. The response time for an implementation like this would be a few seconds, anywhere from 1 second to 3 seconds when you're going out via the internet. Now, if the few seconds of response time is too slow for you, or if connections going via the internet is not secure enough for applications, then there is a lower latency implementation available, which is to utilize either VPC peering or transit gateway and VPC along with VPC endpoints. So the way that works is, again, say you're starting with VPC1 and VPC2. Both are in their own region. You could peer VPC1 and VPC2. VPC peering is an offering specifically from Amazon. So this VPC peering provides a direct connection between VPC1 and VPC2, which will speed up your network between the VPCs. Now, one thing to be aware of when utilizing VPC peering is if you have so it is a one-to-one connection. So if you have two VPCs, you'll need one VPC peering connection between them. Now, if you have 10 VPCs in one region, 10 other VPCs in other regions, so if you want the VPCs to talk to each other, you'll have to create as many VPC peering connections as well. So if you're a large organization, VPC peering becomes unsustainable pretty quickly for large organizations. Like 10 VPCs in one region, 10 VPCs in another region, they all want to talk to each other. You'll have 100 VPC peering connections. Not practical, not really possible to manage quickly, right? Not really possible to manage it efficiently. So for a scenario like that, if you're a large organization, then what you can use is the transit gateway. Again, an Amazon offering. I'm sure other providers also have similar offerings. They must be named differently, but I'm sure other providers also have similar offerings. A transit gateway is like a single hub from which all of your traffic will travel between your VPCs. So no matter how many VPCs you have, how many AWS accounts you have in one region, whenever they want to talk to another region, you could set up transit gateway between your regions, which is a fast connection, fast wire, that you can install between your regions, and all of the connections all of the traffic will flow through the transit gateway. So very efficient when it's a large organization, because there's only one path to maintain. Now, both these solutions, VPC peering and transit gateway, are only going to speed up the connection, the network between your VPCs. So this middle path between your VPCs, these are only going to speed up that. What if in your second region you have a database or you have S3 buckets, that you need to access? After the connection arrives, after the request arrives at VPC2, if you still need to connect to additional services, S3, DynamoDB, those services, remember, those services they have their own VPC. They are not part of customer VPCs. So in this case, VPC2 is a customer VPC. It's your VPC. The services don't run there. So once the traffic arrives at VPC2, you will again be, traversing to yet another VPC if you need to access some data or some other AWS service. So how do you speed up connection from VPC2 to the additional AWS services? What you use is VPC endpoints. So VPC endpoints are essentially, it's an offering that gives your VPC direct connections to the VPCs of other services like S3, DynamoDB, a lot of other AWS services. So this direct connection is going to help you speed up your connection after it has arrived in the destination region. So a combination of VPC peering and VPC endpoints for small organizations, or a combination of transit gateway and VPC endpoints for large organizations is going to be the standard low latency implementation if you want to achieve it. And when you leverage VPC peering or transit gateway along with VPC endpoints, what you're going to see is the response time is going to drop from a few seconds to like hundreds of milliseconds. You'll essentially see a 60 to 80% improvement in latency over the internet-based implementation when you use this particular implementation. Okay, now one very important configuration about application load balancers that I want to cover here is like this single configuration plays a very, very important role in how fast you'll be able to fail over from one region to another. Let me explain why. So say you have a standard multi-region implementation processing synchronous traffic. You have two regions. Both regions have their own application load balancer that is in front of your app in both the regions, and you're utilizing Route 53. Now, if you want to exit a region, you make it so you either invert the Route 53 health check for that region, making Route 53 believe that the region is unhealthy, or you change one of your flags somewhere, that informs the load balancer, hey, this region should be now considered unhealthy, or you shut down your services in one region, and you shut down your services in one region to make the health checks for that region fail. Okay. What you are going to notice for client traffic, synchronous client traffic, is that just because a Route 53 health check is now unhealthy, it doesn't mean client connections are immediately going to reconnect. They are not going to immediately disconnect. The reason for that is client connections were established before the Route 53 health check turned unhealthy. The load balancer, the application load balancer, is the one maintaining the connection pool. So the application load balancer is the one that will keep the connection open even when your Route 53 health check is failing. This is something very important to note, and many this is actually a major pitfall for many application teams. We also discovered this the hard way. So what do you do in a scenario like this. So what happens is the ALB has a configuration setting called keep alive. So the ALB is only going to disconnect a client connection after the keep alive duration expires. And the default duration for ALB keep alive is 3,600 seconds, so 1 hour. So this keep alive setting is the reason why if Route 53 health check for a region is unhealthy, the region keeps, the region in some cases keeps receiving traffic even after Route 53 health check is unhealthy. So how do you get around this problem? Only recently, I think in the last 2 years, Amazon started allowing end users like us to modify this keep alive setting. So what you have to do is you have to set your keep alive to a lower number. 5 minutes is a good starting point. So that way, your application, your client connections will refresh every 5 minutes, and if you need to exit a region, once you make the health check for that region fail, all of the traffic will route to your other region in exactly at the 5-minute mark actually. So 5 minutes is a good starting point. You can test lower and higher numbers. Amazon allows the lowest number to be about 60 seconds, but 60 is pretty, I would say it's challenging, because if you set the keep alive to 60 seconds, it means your clients are going to be forced to refresh their connections every 60 seconds. So that may introduce churn on the client side, and it might result in a degraded experience for your clients if your load balancer is forcing them to refresh their connections too frequently. So, make sure you keep a watch on this number, test it out. The default number is very high, so you need to watch out for ALB behavior when you're testing failover, failback. Okay, the last topic I want to cover today is practicing failover, failback. Practicing is actually mandatory, because if you don't practice, then you and your management are always going to be nervous about whether the second region is going to work. So, if you bring up failing over your application and failing back, and if there is nervousness in the team, that means you haven't practiced enough yet. You have to practice so many times that it becomes a non-event for your team, for your application, for your infrastructure. Like you should be able to, you should be failing over multiple times a year as practice, if not out of necessity. Okay. So, and one thing to keep in mind is that you should execute your failover, failback testing with your peak expected load, not the steady state load. Like if you're receiving 2 to 3 requests per second for majority of your day, but there is a specific hour or window where you're going to receive 200 requests per second for a few minutes or a few hours, then you need to do a failover in the middle of processing the peak traffic that you're going to receive, in of course in a non-production environment for testing. So that is going to, if you are successfully failing over at your peak expected load, then your environment is ready to be failed over during any disaster. Now, extended failover. I recommend applications perform extended failover at least twice a year. By extended failover, what I mean is you fail over from one region to another and stay in your new active region for a good number of days, 7 days, 10 days, 15 days, So essentially build the confidence to show or to demonstrate that you will be able to run out of any of your regions for extended durations if there is a need. So, and I would recommend performing extended failover at least twice a year. Now, and also you should begin failing over, failing back as part of regular operations. Like things like if you're executing a large release, and there are some risky changes in that release, right? Then what you could do is, you take one region out of rotation, you deploy all of the changes there first, there you do your validations, then move traffic to the region that you just validated, and then perform the same activities in your second region. Blue green, the simple name for this is blue green, right? So make failover, failback a regular part of your operations to gain confidence that you'll be able to run in any of your regions if you so desire. Conclusions. Very quick set of conclusions, which is no infrastructure is fail-proof. Neither on-prem infrastructure nor cloud infrastructure is fail-proof. AWS and Azure had outages this year. Last year, Google Cloud wiped out somebody's cloud account, and they had to restore it. So I'm sure there was a few hours of disruption. I forget whose Google Cloud account it was, but they did wipe out somebody's account last year, right? So no infrastructure is fail-proof. You will need to practice, implement, and practice, prepare, implement, and practice resiliency. If you went through those questions I presented in the beginning, and you realize that you will have significant impact if there is an extended cloud outage. So thank you all for listening to me for a whole hour. Here are some QR codes you can look at. These are the QR codes to join the community, and I'm told that you can submit your talk here. And here is some of my contact information. You are welcome to reach out to me on LinkedIn or at my email. Thank you. That's it. I'll stop talking now.
Thank you, Jimmy, for that incredible and great talk. Thank you, all people, all 50 people who have been connected with us, getting the great value that Jimmy gave us. I think that this incredible talk is very valuable for different architects in Latin America. I think I hope that you have enjoyed this talk and use this knowledge in different industries. See you soon.
There is one question out there. You can finish your thoughts, and then we can cover that question.
We can use this question. The question is: cloud is becoming a single point of failure. Do you think that we need to change the cloud strategy?
Managements. Okay, I have an answer for this. So managements across the United States after October 20th, after the October events, managements across the United States have started asking this question: What if we are not able to recover from cloud failures? Now, what I will say, my opinion, is that if you look at the AWS outage was in a single region, US East 1. So if you were running on AWS, just being in a second region would have been enough for you on October 20th. It was enough for us. Our application, as soon as US East 1 started experiencing DNS failures, our application automatically failed over to our other region. So being in the second region is what saved us. Now, for Azure, the outage was not specific to one region. It was across all of the regions. And to address something like that, there are a couple of solutions that management within JPMC has now started discussing, which is do we need to be in multiple cloud providers? Like, should your application be deployed to AWS as well as one additional cloud, Azure or Google Cloud? That's one strategy. The other strategy is, should your application, maybe your application should be deployed to the cloud. And if you are a very critical, systemically important application, also deploy the application on premise. Both of these strategies are valid. Some companies are using it, like Snapchat, for example. Snapchat already has their infrastructure in multiple regions. If teams have, it just needs the right amount of budget and the right amount of people. These strategies are definitely valid strategies, and one of them should be selected.
Okay, perfect. I think that this topic is very interesting. Actually, I think that we can talk in another session about GitOps and how to use the mix between GitOps and Kubernetes and how to use this working with multi-cloud architecture. I think that this topic is very interesting. We can talk in a series of Kubernetes, I think, and how to use the Kubernetes for multi-cloud. We have to think, but I know that we need another session about this topic. Is very interesting. Your talk is very valuable, Jimmy. Thank you so much, everyone, for enjoying this talk with us. If you have some additional question, please reach us to talk about that. And see you soon in the next session. Thank you, Jimmy. I hope you stay in as soon as possible in another session talking about this topic. Thank you so much. See you soon. And
thank you. Happy holidays.
Yes, and don't forget joining to our incredible ArquitecTI community. Thank you so much. Thank you.
Thank you.
Bye. Thank you, Jimmy. Thank you.
Thank you, Nicholas.